Hello. Hello, everybody. I'm Laurent Tardif, and I'm very happy to be there to talk about continuous integration. In this talk, I will try to share what I've learned from 25 years now, basically, of continuous integration, continuous deployment, and every practice related to have a better feedback loop for developers. At the end, we will have a few time for questions, so do not hesitate to ask. So, let's start. Basically, I started 25 years ago in software. I was working for a startup, and the startup grew quite quickly, and we were a scale-up, and we were acquired by Yahoo a few years after. So basically, I start from a team of 5 people, and we go up to 100, and after we work for more than 1,000 engineers company. So during this quick evolution, I've learned a lot of stuff. And after that, I work for Agilent Technology. I work also for Zenika today. And I saw a lot of engineering team, a lot of continuous integration platform. And from this learning, I've tried to summarize the key points I've learned during this time. So basically, the oldest system I've seen in my life was clearcase, and basically the idea was to see from clearcase to now what have changed in continuous integration and how Maven, Git, Docker have changed a lot continuous integration process. At my starting, I was a backend developer, so the talk will be Java related, basically, but I will reference other technology during the talk. So do not hesitate if you are not Java familiar. I hope this talk is for everyone. So before starting, let's explain a bit how my slide will be organized. At the top of the slide, I will cover the time period. I've split the time in 6 periods. This is approximative, so do not blame me for that. And I will look first at the run aspect. So the run is everything related to the run aspect of a system. It can be Docker, Kubernetes, Ansible, this kind of technology. I will have a look also at the main language at this time. As example, at the beginning, it was mainly C and C++. So the beginning was the 80s, so nearly 40 years now. Just to illustrate the beginning, not the beginning of the software, but beginning of continuous integration like system. The second layer will be everything related to the build. So the build is Maven, Ant, this kind of technology. Of course, the source control management, like CVS, Perforce, this kind of stuff. And the orchestrator, what I call orchestrator is the glue between the build, the source control management, the language, and everything. Of course, it looks like Jenkins, GitLab CI, GitOps, or whatever practices. So just to give you how the stuff will be related. So at the beginning, in the 80s, we just remove my face for 1 minute, just to allow you to see nicely the timeline. So the idea is, in the 80s, we were working with C++, Makefile, CVS, Perforce, and clearcase also. Clearcase is, for those of you who don't know it, it's a mix of SCM, build mechanism, interface graphic also for authoring the source file. It's everything embedded. It was the IBM system. It's a one-in-all system which was centralized. So at this time, the main issue we have is the links between the software we were building and the operating system. The libc was very system dependent, server dependent even. So moving a software from one server to another one was a mess. Basically, when we install a software, basically we recompile it It was quite common at this time, just to recompile and to make a static or dynamic links with the system library. So the build we were doing was very system dependent. And as an example, at this time, I've met a team where basically one guy made what we call the build of the third Wednesday of the month. Why the third Wednesday of the month? Because it took him nearly 1 week to merge the branch, to try to compile successfully the software, not even having a bug-free and a running software, just to compile it, just to give you an idea where we start 40 years ago. And despite that, the binary were non-portable from one server to another one. So that was very difficult to share binaries and to deploy a software. It was quite common to have something working on the developer or the server we work, but to have it running somewhere else, it was difficult. Not impossible, but difficult. And it took time for that. The first major evolution from my point of view was the Java language appearing. The key idea of the Java was compile once, run everywhere. So that was very important because it tried to remove the dependency with the system. That was not perfect. That was not the magic solution to all the issue, but at least when you build a jar file on your server, you are able to run it somewhere else without too many problems. So it reduces a lot the effort to make it runnable on several servers. And side effect of that, it was also the beginning of continuous integration. Not what I call the beginning is the first version of Continuum, Cruise Control, this kind of tool that allow a team to build on a regular basis their work. It was not only the side effect of Java, it's also the team starting to become bigger and bigger, even sometimes distribute across the world. And the teams understand that having something difficult to install or to deploy, it's a mess. So we start to build on a regular basis to have something running somewhere else than on our server. As example, CVS was a source control management system. It's mainly based at the file level. What I call the file level, it was quite common to forget to commit one file. And the system don't just tell you a little warning. If we look at Git today, Git work at the repository level. So you commit the whole system and the whole repository makes sense. Git, it was the file level, and it was more easy to forget to commit one file or to push one file. So it was important at this time, even to check that when you commit or you push your version of your repository, that you publish everything. It was also the beginning of Ant. Ant, Makefile was very designed to build binaries. Basically, you have a set of C files, you build object file, you build libraries, and that's it. Without you start to add some extra step, like tools like PMD, find bug, check style, to check either the syntax or to identify some potential bug or bad coding practice. It's the beginning of Sonar behind. And it was so complex that it took nearly a full-time engineers to do that. And we call that the build master at this time. To give you an example of the complexity, the build itself of Ant itself was nearly 2,000 lines of XML, just to describe the build process, something that we can do in 5 lines today. So that was the beginning. But let's start. So Java become more and more popular. The web start to develop. We can have multiple steps in the build. We talk about build lifecycle. Unit tests become more and more common. That was the beginning of Git. We were a bit earlier, before 2010. We start to have multiple language in in the project. So we do not have only Java file, we have also PHP or some other language. So a project was not only made of one programming language. So that was important because continuum and cruise control was not so easy to have several language. So that's also the beginning of Hudson, the father of Jenkins, for those of know. It's also the beginning of the DevOps movement. Development teams start to become more and more efficient, and we start to share libraries, not only source code with Archiva, for example, and we start to automate deployment. And we see different kind of tool coming. From my point of view, some of the tool came from the development team. It was quite common because teams become more and more efficient, need to deploy their environment, and they need a tool to automate that. And we have some tool that came from the developer side. In parallel, operation team need also a tool, and some tool came more from the operation teams. Now with Docker and Ansible, we see that both teams use the same tool, but at the beginning, it was quite common to see development team using one tool and operation team using another tool. It's a good waste of time. So, and it's also the beginning of Sonar. So using a static code analysis tool became more and more common. And we start to have a global view of the code quality of the project or the set of projects for a company. And of course, I start as a build master, I start to customize everything because the tool allows me to customize everything. So I did it. And I think my build are very specific to my project. I download source, I download dependency, I compile, I run test, and package and generate the package, and I'm running code quality tools. And in fact, everyone do that. And Maven was the first time that we start to promote convention and standardization versus too much customization. The plugin mechanism was a good idea, but introduced a lot of dependency. And this is a key point. Take care when you are using a build or whatever tool, generally speaking, with a lot of plugin. It's become difficult to maintain the consistency across the production line. Maven, you can add thousands of plugins to have fancy report and whatever you want. In Jenkins, you can add also the plugin to do the same stuff, but you need to have everything in sync. So that means that if several teams use the same Jenkins, the several teams need to be in sync. And you add a bottleneck between all your teams. That's not a good idea, generally speaking. Try to be more independent as possible from your infrastructure. At the beginning, it was already nearly 20 years, but we are still dependent. There is a strong coupling between the JDK and the tool itself. And because we were massively Java at this time, in fact, you had a strong dependency between the Java version you are using on your project and the Java version of your Hudson. This is not an issue if you are alone, but if you work with 10 teams, it starts to have a coupling between the 10 teams because the day you update Hudson or Jenkins, you update the Java version of all your project. Not a good idea also. And it was a time where there is a lot of change in the Java world. To give you an example, Log4j, which was a key library for logging. There was nearly 20 versions in 5 years. So that's very important. And having a regular update of all the project and the infrastructure was a key point. So let's have the time between 2010 and 2013, basically. I think it was a major change. Of course, JavaScript started to become more and more important for the front end. So Node.js, beginning of Angular. That was an important change. In the past, we have Java, PHP. Now we have Java, PHP, Python, JavaScript, so a lot more programming language, more heterogeneity between projects. It's also the beginning of GitHub and GitLab. That's the beginning of Jenkins because of the split between Hudson and Jenkins. it's time where we start to have multi-version of the tooling. So in Jenkins, we start to be able to specify multiple JDK and to specify which JDK we want for each project. So we start to cut the strong dependency between the tooling of Jenkins itself and your project. It's the beginning of Artifactory and Nexus to deploy binaries. The binary is bigger and bigger. And that's it. At the beginning also of microservice. In past, we were mainly mainframe, big system. With the beginning of the web, e-commerce and whatever, we start to split in small project and in small module. So from one big binaries to deploy, we start to have more and more projects. And so it costs us more and more to maintain all this build. That was the beginning, as example, of the versioning of the binaries in Maven with the pump parent as example, and where we can stick the version like the log file in JavaScript. So it appeared only 5 years after Maven, basically. So it took time to understand that it was important to fix dependency between projects. So that's the evolution. So we start to be able to manage version. And the challenge at this point of time was to managing the test environment. The test was difficult to... unit tests are easy to deploy, of course, but when you have integration tests, when you have a performance test, when you have functional testing, it's become difficult to deploy the environment because you need to deploy JDK, you need to deploy Tomcat as example, you need to deploy your jar file, your configuration file, and automate this installation become more and more complex. And we'll see that the next step after this period was the beginning of Ansible, Docker, which was an easy way for developers to deploy infrastructure and to use the same tool than production of teams. That was important. And also, for me, one of the key points at this point of time was the beginning of Circle CI. We were the first to introduce the concept that the job description was part of the source code. That was very important. Jenkins and Hudson and everything in the past, the configuration file of the build was on the server side, not linked to the code. So that means that you have several branches. You need to do an evolution of your build mechanism. You impact all your branch, all your version. And when you are something in production and you want to update, you need to update the future, the present, but also the past. And either you're not able to build anymore, or you do a duplication of your build system to be able to build the past and the present. That was a mess. Circle CI was the first teams that basically introduced the concept that the configuration file itself, is in the code. That's very important because that means that you can have several versions of your build mechanism. That means also that you can have a branch to test your build change, and that was very important. And it took some years to have that in Jenkins. So now it's quite common to have all the build mechanism use a descriptor inside the code. That's very important. That's a very, 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 very important key point. Just to make it, if we look at the past, we have that in clearcase 40 years before. So we start to isolate everything, but that was not a good idea for some point. And we start again to link stuff that need to be links. How you build the code is part of the code. It's part of the life of the code. That's very, very important. So just to have a quickly, now in Jenkins, so basically a bit more than 5 years ago, we were able to have a different JDK version for runtime, for dependency management, and we're able to run Docker. So we are able to isolate every process nicely. Of course, we can do that in a GitLab and GitHub CI that that focus on what's happened. And this isolation is very important because you made your build mechanism, you made your whole tooling independent from the operating system or the orchestrator lifecycle, and that's a very important key point. So also the key point is now it's quite common to have a lot of tools that do not require a lot of customization. And that was one of the key points. If your project needs customization, you need to spend 5 minutes to ask why. I've seen hundreds of projects. I work on large systems, small system, fast scale-up system. In fact, it's very rare that you need strong customization. And over time, every team that did customization in their build process were stuck with this customization because it was too much expensive to remove them or to move to another system. And you will see at the end the picture of the evolution of the continuous integration ecosystem during these 40 years. That was very impressive. There is thousands of tools involved, lot of customization, lot of stuff, and it's quite impossible if you are linked or strongly coupled with your infrastructure or your build mechanism or whatever to migrate. So take care not to be too much linked to your tooling. So to try to make a quick summary of what we see, keep in mind that if you want to do continuous integration, is to work in parallel, and it's not because you want to be able to commit in a feature branch where you are alone for 6 months. Now, continuous integration is integrating code with the team on a regular basis, several times a day. You share with the team and you update from the team. That's very important. I do not talk about documentation with a key point in software, and of course, my point of view is your doc is part of the code, so with the code, update at the same time and linked, and that's a very key point. Okay, so because I have 2 minutes left, I will not talk too much on that. Keep in mind, there is no magic solution that fit all your needs, all your requirements. So keep in mind, when you choose a tool, what do you need? One tool is simple, but you may stick at some point. Several tools is easier and you can do fancy stuff, but you need to get a consistency between all the tools. That's balance between the two approaches you need to take care. And the key point is try to be to have a low coupling between all your tool and your code to make it more easier to evolve. When you want to choose your next tool for continuous integration, try to keep in mind that the design should follow the current standard. It should be scalable. It should provide you a standard pipeline. The pipeline should be easy to diagnose, to restart. It should be able to run in parallel. So it should also, for example, if you move to monorepo, your pipeline should be able to handle that easily. And so that's a key point to keep in mind. So in summary, this is a subset of the tool. If you look on the internet, you may find thousands of tools involved. I just put some key points here. So it's a system that evolves a lot. If we look at the beginning, on the top, we see that we, at the beginning, customize the build mechanism with unit tests, with code analysis tool and this stuff. After, we simplify the build process itself in parallelization, in dependencies, with caching mechanism. Now it's more an acceleration of the change in the deployment process with Docker, Ansible, that makes stuff easier to develop. It's continuous changing mechanism. Also, there is a new challenge. So, for example, big data. You do not build a big data project like you build a software project. There is also a lot of tools that try to make the integration of the several programming language in your company more easier. If you want to look at Bazel, Canico, Launchable, there is a lot of tools. So that's it for today. I think I took 25 minutes, so it let us some times for question. So feel free to ask, and thanks for your time. I hope you have learned something, and my slide will be available at the end of the conference. So have a nice day. Thanks for your time, and time for question now. Thank you.